First, pause the movie and read the question. Let's imagine the situation. You go to the restaurant, you eat some food that costs 500. 500 is the cost of your food. Assume first you pay the tip. The tip is 20% of the bill. So you pay 10% of the bill. So if you pay 10% on the top of the bill, you will end up to 110%. So your multiplier is 1.1. You increase by 10%. You need to pay 100% the cost of the food plus 10% more. Now, this is when you pay first the tip. But now you get 15% discount. If you get 15% discount off this, your multiplier is 0.85. Because you end up with 85% of the amount paid. So this is going to be what you pay for your at the restaurant for the food. Let's look at the second option, where first you get the discount. So your food costs 500. If you pay 15% the discount first, you need to pay just 85% of your bill, because 15% is a discount. So you just pay 85% of the bill. And this is what you pay with a discount. But now you need to pay 10% tip. So if you add a 10% tip, you'll pay 110% of this amount. So you end up with 110%. 100% the food plus 10% the tip. As you see, both models will end up to the same amount. So it doesn't matter in which order you pay. Do you pay first the tip and then you get the discount, or you get first the discount and then you pay the tip? You end up with the same amount. Question B. Would your answer be different if the value of the food is different? The answer is no. No matter what is the price of your food, no matter what number is in this box, the calculation will be the same, because it doesn't matter in which order you multiply, you get the same answer. So the answer is the same in the sense that it doesn't matter what you pay first. You pay first the tip and then you get the discount, or you first get the discount and then you pay the tip. Question number 2. Please pause the movie and read the question. I will show you how easy it is to use a multiplier in this question as well. If the shortest size is increased, we miss a D here, it's increased by 10%, then the shorter side becomes 10. If it's increased by 10%, then it becomes 110%. So it becomes 10 times 1.1. The longer side is decreased by 25%. So it will become 15 times. If it's decreased by 25%, you end up with 75% of it. So you end up with 75% of 15. So this will be the new longer side. Therefore, the new area will be the new shorter side times the new longer side. And it does not really matter in which order I multiply, so I multiply these two separate, 150 times, and then I multiply these two separate, and when I multiply 1.1 times 0.75, I'm using my calculator and I get 0.825. What is a percentage change? I don't need to multiply these two numbers together because see, this one is the old area. So practically I end up with 82.5% of the old area. But the old area was 100%. So 100% minus 82.5%, which I end up to, is a 17.5%. So the percentage change is 17.5, 17.5% decrease because it's less than 100%. No matter what are my starting points, my starting sides, if I increased one by 10% and I decrease the other by 25%, I still end up with a 17.5% decrease in the area. Okay, a t-shirt, no matter what's the initial price, I don't know, I'll just call it t-shirt, is reduced by 7%. If we reduce by 7%, we end up with 93%. The initial. Initially it was 100%, reduced 7% is 93%. Then this is a new t-shirt value. If I reduce by 10%, I end up with 90% of that value. So I don't really need to know what was initially the t-shirt, doesn't matter, I copy it here, whatever it would be. But these two together multiplied give me 0.837, which means that I end up with 83.7% of the initial value of the t-shirt. So 83%, 83.7% represents a 16.3% decrease or reduction.